Oh, right.
You, what is that? Kill it. No, come here, Juke. I've had enough of your stupid left tracks.
Oh, what are you gonna do?
I'll...
Enough. I'm doing something here. Can you guys leave?
Fun.
Anyway, maths. It's not exactly everybody's favourite subject, but it's important. Which is why I'm here to teach you everything in maths that I know at the moment. Now, out of all of the branches in maths, arithmetic is probably the easiest to grasp. It relies on four main fundamental operations: addition, subtraction, multiplication, and division. Now, I'm sure everybody watching this knows how to use these, but we don't usually take a deeper look into what these operations actually are and what they do. For example, addition, which adds the value of one number to another, is just repeated succession. Wait, succession? That's right, the successor function is essentially the most fundamental operation. In simpler words, you're just adding 1 to your number. So, s of 2 would be 3, s of 5 would be 6, and so on. However, we don't really use this function, as we kind of instinctively know which number comes after one another. So, how does this define addition? Well, think about it. Let's do 2 plus 3, which equals 5. This is the same as doing 2 plus 1 plus 1 plus 1. Or essentially applying the successor function 3 times. But since we don't want to write plus 1 repeatedly, we just write plus 3. So you're starting with 2 and applying the successor function 3 times to get 5. However, I'd highly suggest that you don't use the successor operation in most of your basic arithmetic. Take a look at this. This is 23 plus 32, with the successor function, by the way. Anyway, with that out of the way, now we can move on to... Addition is widely accepted as the act of adding the value of two numbers together. So if I had a set of 5 objects and another set of 6 objects, then altogether I've got 11 objects. Addition has a special property. It's commutative, which means that if you swap A and B around, you'll still get the same answer. Now we're going to move on to addition's inverse operation, which is... Subtraction is like addition, but in reverse. Instead of adding the value of two numbers together, it takes away the value of a certain number from another number. Unlike addition, subtraction is not commutative, which means that you'll get a different answer every time you swap A and B around. Now, remember when we said that addition was repeated succession? What would repeated addition be? That's right, multiplication is just repeated addition, in a sense that you're adding A to itself B times. So, in other words, A times B. The weird thing is that there are multiple symbols for multiplication. You have the typical cross, the asterisk, and the dot product. You can also enclose the number inside of brackets, indicating multiplication. Like addition, multiplication is also commutative. The inverse of multiplication is called... Division is widely accepted as the act of splitting a number into an even amount of groups. But considering that this is the inverse of multiplication, it's also repeated subtraction, in the sense that we start with A and subtract B from it repeatedly until we get to 0. The amount of times that we subtract B from A is our answer. So let's do 6 divided by 2 as an example. First off, we'll start with 6, and then we'll subtract 2, which equals 4, and then we'll subtract 2 again, which equals 2, and then, finally, we'll subtract 2 again, which equals 0. We've subtracted 2 from 6 3 times, so that means that 6 divided by 2 equals 3. That's more so the mathematical explanation of it, but there's a more so practical way of explaining division. Like if I had 6 objects and I wanted to split them in 2 groups, then I would have 3 objects in one group. Right, well, that's all of them, right? I'm done?
You're not done.
Wait.
You're not exponentiating.
What? So, you know how I said that multiplication was repeated addition? Well, exponentiation is repeated multiplication. Exponentiation is usually written as a to the power of b. Using our knowledge of how operations are usually repetitions of the operation below it, we can easily use exponentiation.
You also forgot roots and
God damn it!